Hey Matrix, welcome to the next video in the Maths Paper 1 playlist. Today we're going over question 7 of the November 2020 past paper. If you don't have the paper, then please pause the video. There's a link in the description below where you can download the paper as well as the memo. Once you have the question, we can continue with the video. Okay, let's get started. So question 7 is a relatively short question. So it's the first question of the paper that deals with the calculus part of the maths. So what I want to do is quickly, I just want to explain a limit, because you have to use limits in your first principle, and often it's not too clear where it comes from and why we use it. So when dealing with the limit of something, it's normally the limit as h goes to 0, let's say for first principle. Okay, so why is that? So first of all, recall that my gradient is the change in y over the change in x. Okay, so we have 2 points. Okay, so x2, y2, x1, y1. Okay, so we have these 2 coordinate points. Now, when we're looking at a limit, okay, what we're asking is, or what we want to interpret is, what happens to the function, okay, as we tend to the point which we're dealing with. So for first principle, okay, so first principle is given as this: f prime of x equals to the limit as h tends to 0 of f of x plus h minus f of x all over h. Okay, so what does this mean? Okay, well, we know that we have x1 over here and we have x2 over there. Okay, so let's call the distance between x1 and x2 h. Okay, so that's h. Okay, so now from our gradient we can see that the gradient is y2 minus y1, but we can rewrite y's as f of x. So we can have f of x2 minus f of x1 all over x2 minus x1. Okay, but can you see that x2 is a distance of h away from x1? So x2 can be written as x1 plus h. Okay, so therefore I get f of x1 plus h minus f of x1 all over x2 minus x1. Now, the distance between these two is called h. Okay, so I'm looking at this interval here. Okay, therefore we can replace that with h, so we end up with f of x1 plus h minus f of x1 all over h. Okay, now when we take the limit, what we're asking is, if I make this interval over here extremely small, what is happening to the function? Okay, so I'm going to make h tend to 0. So if I let h go to 0, meaning that this interval becomes so small that it looks like it doesn't exist, what happens to the function? Okay, and that's why we take the limit as h tends to 0, because this interval h, which is the change in x, is decreasing almost to nothing, to a single point, and that's what we want to see what the function looks like at that point. Okay, and that's how a limit works. So we're decreasing this interval over here, okay, all the way to the point where h looks like it doesn't exist anymore, and that's why we take the limit as h tends to 0. Okay, now let's start with the question. So 7.1 says determine the derivative f prime of x, okay, from first principle, and there's our function. Okay, so we have the first principle set up over here. Okay, so the first thing is get f of x plus h. Okay, so f of x plus h. That means for every position of x in my function, I substitute x plus h in. So that's then going to be 2x plus h squared minus 1. So if I sort that out, I'm then going to get 2x squared plus 2hx, okay, because it's a positive there, plus h squared minus 1, which means I have 2x squared plus 4hx plus 2h squared minus 1. Now I substitute this and the function into my formula. So limit, okay, you always have to take the limit h tends to 0, of f of x plus h. So put everything in brackets. That's 2x squared plus 4hx plus 2h squared minus 1. Okay, minus my original function, so put it in a bracket so that you don't forget to distribute the negative. 2x squared minus 1, and that is all over h. Okay, now distribute your negative in, and the key with first principle is every term that doesn't have an h in needs to cancel out. That's when you know you're on the right track. Okay, so the limit as h tends to 0. Okay, that's 2x squared plus 4hx plus 2h squared minus 1 minus 2x squared plus 1. Okay, remember to distribute your negative in. Okay, so now we can see this doesn't have an h, that cancels out. Oh, this is all over h. Okay, minus 2x squared and 2x squared, that also cancels out. So now we only have terms with h in it left over. So we have the limit as h tends to 0, 4hx plus 2h squared all over h. Okay, so we can see there's a common factor at the top. I can take out h as a common factor and it will cancel out at the bottom here. So I'm left with the limit as h tends to 0 of 4x plus h. Okay, now most of the time you get told you can just substitute the 0 into the h place, and there we go. But what is it asking? It's asking that if I have h and it's moving towards 0, so let's say I have here and there's 0. So let's say h, okay, h is a constant at this point in time, but if I'm tending towards 0, so I'm getting closer and closer to 0 for the value of h, what is h going to be? Okay, so if I come from any direction, so as I get closer, what's happening? H is becoming 0. That's why h goes to 0, and we can substitute 0 in there. Okay, so then we'll end up with the function of 4x. F prime of x equals to 4x. Okay, now let's have a look at 7.2.1. 7.2.1 says determine the following derivative. Okay, so whenever it's given as a square root, the easiest thing to first do is write in an exponent form. So I'm going to write d dx of, because it's the fifth root, okay, the 5 goes to the bottom, so it's x2 over 5 plus x cubed. Okay, now we can do the derivative of each one on its own. So d dx of x to the 2 over 5 plus d dx of x cubed. Okay, so how does it work? We minus 1 from the exponent, and we take this original exponent and we multiply it by the number in front. Okay, so because it's a 1, this becomes 2 over 5x, 2 over 5 minus 1, plus 3x, 3 minus 1. Okay, sorting all this out, we'll end up with 2 over 5x. Now, this can be written as 5 over 5, so 2 minus 5, that's negative 3 over 5, plus 3x to the power of 2. Okay, not too difficult. Now, the last question says, determine f prime, okay, so the derivative of the function, if f of x is given by that, and then they say that x cannot equal to negative 3 over 2. Okay, now if you don't take AP Maths, you don't know how to do this. Okay, so we need to simplify it in order to get it to a form where we can do the derivative. Okay, so if you notice here, okay, it's the difference of two squares at the top because it's a 4 and a 9, so they both can be squared and x can be squared, and at the bottom I can take a factor of 2 out. Okay, so 7.2.2, we have the function f of x equals to 4x squared minus 9 all over 4x plus 6. Okay, so I take out the common factor, so that's going to, or I'm going to factorize the top first, sorry. So that's going to be 2x minus 3 and 2x plus 3. All over, taking out the common factor of 2x plus 3. There needs to be a 2. Okay, therefore this bracket and that bracket cancels out, and I'm left with 2x minus 3 all over 2. I can split it because there's a minus at the top, so that's 2x over 2 minus 3 over 2, which then just gives me x minus 3 over 2. Now I can take the derivative of this because I know how to do it. That's to the power of 1. That's a constant, so it becomes 0. So f prime of x equals to 1 times 1 is 1, x 1 minus 1. So I'm just left with 1. Okay, and that's how we go about doing this question. Okay, if you found today's video helpful, then please leave a thumbs up on the video. It does help a lot. If you have any questions regarding question 7, please leave them in the comment section down below and I'll get back to them as soon as possible. Please go check out the YouTube channel as well. There's chemistry, physics and maths paper 2 videos available. While you're there, please consider subscribing to the channel, and remember, it's never too late to have an OIC moment.